The number 8 solid bonding conductor doesn't need to be a continuous loop. It can be connected to the bonding grid at multiple points. The bonding grid is formed by the metal walls, coping, and brackets of the pool. Therefore, you can connect the number 8 solid to the grid at any point that is convenient for bonding external equipment. According to National Electrical Code Section 680.26 C2, the number 8 solid bonding conductor must be connected to the reinforcing steel using an approved grounding connector or other listed means. A mounting lug is not required if the rebar is wire tied together at an intersection and the overlap is sufficient to ensure a secure electrical connection. The bonding conductor can be connected to any exposed rebar within 5 feet of the pool. It is not necessary to place a mounting lug on each individual piece of rebar. Recommended bonding practices include firstly connecting the number 8 solid bonding conductor to the metal walls, coping, and brackets at multiple points around the pool. Secondly, using split bolts or other approved grounding connectors to connect the jump wires. Thirdly, connecting the number 8 solid bonding conductor to the rebar using wire ties or an approved grounding connector. Fourthly, ensure that the connections are tight and secure. And fifthly, inspect the bonding system regularly and tighten any loose connections. The intent of equipotential bonding is to create an electrical connection between all metallic parts within and around a swimming pool, hot tub, or spa. This minimizes voltage gradients in the area, reducing the risk of electric shock. Here's a more detailed look at the key aspects. Firstly, bonding grid. The bonding grid typically consists of the pool's metal structure, any metal fittings, the metal parts of electrical equipment associated with the pool, and any metal within a certain distance of the pool. Secondly, bonding conductor. A solid copper conductor, typically number 8 American wire gauge, is used to connect all these metallic elements to the bonding grid. The size of the conductor is specified by the National Electrical Code. Thirdly, connection methods. Connections must be made using listed bonding connectors or other approved means. These connectors ensure a reliable electrical connection that can withstand corrosion and mechanical stress. Fourthly, rebar bonding. If the pool deck or surrounding area has rebar, it must also be bonded. The bonding conductor is connected to the rebar at multiple points to ensure it is part of the equipotential plane. Fifthly, equipment bonding. All metal parts of electrical equipment, such as pumps, heaters, and lighting fixtures, must be bonded to the grid. This includes the metal conduits and enclosures that house the wiring. Sixthly, water bonding. In some cases, the water itself may need to be bonded. This is typically done by installing a metal plate or electrode in the water and connecting it to the bonding grid. This is especially important in pools with saltwater chlorination systems. Seventhly, purpose of equipotential bonding. The primary purpose of equipotential bonding is to reduce the risk of electric shock by creating a low impedance path for fault current to flow back to the source. This helps to quickly trip the circuit breaker or ground fault circuit interrupter, interrupting the flow of electricity. Eighthly, minimizing voltage gradients. By bonding all metallic parts together, equipotential bonding minimizes voltage gradients in the area around the pool. This means that if a fault occurs, the voltage difference between any 2 points will be small, reducing the likelihood of a dangerous shock. Ninthly, importance of proper installation. Proper installation of the bonding system is crucial for its effectiveness. All connections must be tight and secure, and the bonding conductor must be properly sized and routed. Tenthly, National Electrical Code requirements. The National Electrical Code, specifically Article 680, provides detailed requirements for equipotential bonding of swimming pools, hot tubs, and spas. It is important to follow these requirements to ensure a safe and compliant installation. 11thly, inspections and maintenance. The bonding system should be inspected regularly to ensure that all connections are still tight and secure. Any loose or corroded connections should be repaired or replaced immediately. 12thly, qualified electricians. Equipotential bonding should be performed by a qualified electrician who is familiar with the National Electrical Code requirements and proper bonding techniques. It is important to choose an electrician who has experience with pool bonding to ensure that the job is done correctly. 13thly, grounding versus bonding. It's important to distinguish between grounding and bonding. Grounding provides a path for fault current to flow back to the source, while bonding creates an equipotential plane to minimize voltage differences. Both are important for electrical safety. 14thly, common mistakes. Common mistakes in pole bonding include using undersized conductors, making improper connections, and failing to bond all metallic parts. These mistakes can compromise the effectiveness of the bonding system and increase the risk of electric shock. 15thly, benefits of equipotential bonding. Equipotential bonding provides a significant level of protection against electric shock in and around swimming pools, hot tubs, and spas. By minimizing voltage gradients, it reduces the likelihood of a dangerous shock, even if a fault occurs. 16thly, understanding local codes. In addition to the National Electrical Code, local codes may have additional requirements for pool bonding. It is important to check with the local building department to ensure that the installation complies with all applicable codes. 17thly, retrofitting bonding systems. If an existing pool does not have an adequate bonding system, it may be possible to retrofit one. This can be a complex project, but it is important to improve the safety of the pool. 18thly, above-ground pools. Above-ground pools also require equipotential bonding. The requirements are similar to those for in-ground pools, but there may be some differences depending on the construction of the pool. 19thly, hot tubs and spas. Hot tubs and spas also require equipotential bonding. The requirements are similar to those for swimming pools, but there may be some additional requirements depending on the features of the hot tub or spa. 20thly, importance of documentation. It is important to document the bonding system, including the location of all connections and the size of the conductors. This documentation can be helpful for future inspections and maintenance. 21st, working with inspectors. When installing a pool bonding system, it is important to work with the local electrical inspector to ensure that the installation complies with all applicable codes. The inspector can provide valuable guidance and help to identify any potential problems. 22ndly, understanding ground fault circuit interrupters. Ground fault circuit interrupters are an important part of pool safety. They are designed to detect small amounts of current leakage and quickly interrupt the flow of electricity. All circuits that serve pool equipment should be protected by ground fault circuit interrupters. 23rdly, surge protection. Surge protection devices can help to protect pool equipment from damage caused by lightning strikes or other electrical surges. These devices should be installed at the service panel and at any subpanels that serve pool equipment. 24thly, regular testing. The bonding system should be tested regularly to ensure that it is still effective. This can be done using a multimeter or other testing equipment. 25thly, safety first. Electrical safety should always be the top priority when working on pool equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician. 26thly, common misconceptions. There are many common misconceptions about pool bonding. One is that it is not necessary if the pool is not used frequently. Another is that it is only necessary for in-ground pools. These misconceptions can lead to dangerous situations. 27thly, addressing specific issues. If you have any specific questions or concerns about pool bonding, it is best to consult with a qualified electrician or electrical inspector. They can provide guidance based on the specific situation. 28thly, continuous improvement. Pool bonding technology and techniques are constantly evolving. It is important to stay up to date on the latest developments to ensure that your pool is as safe as possible. 29thly, proper wire selection. Use only approved copper conductors for bonding. Aluminum wiring is not suitable for bonding due to its corrosion potential in wet environments. 30th, maintaining connections. Protect connections from corrosion by using waterproof connectors and applying corrosion-resistant compounds. This will ensure long-lasting and reliable bonds. 31st, understanding impedance. Low impedance is key to effective bonding. Ensure that all connections are tight and free of corrosion to maintain a low impedance path for fault currents. 32nd. Avoiding dissimilar metals. Avoid mixing different types of metals in the bonding system to prevent galvanic corrosion. Use compatible connectors and fittings to ensure a stable and reliable system. 33rd. Proper conduit installation. When running bonding conductors and conduit, ensure that the conduit is properly grounded and bonded. This will prevent the conduit from becoming energized in the event of a fault. 34th. Protecting bonding wires. Protect bonding wires from physical damage by routing them in a way that minimizes exposure to traffic, equipment, and other potential hazards. 35th. Labeling and identification. Label all bonding conductors and connections to facilitate future maintenance and inspections. This will help ensure that the system is properly maintained and that any issues are quickly identified and resolved. 36th. Documenting modifications. Document any modifications or repairs made to the bonding system. This will help maintain an accurate record of the system's history and ensure that any changes are properly accounted for. 37. Seeking professional advice. When in doubt, seek professional advice from a qualified electrician or electrical engineer. They can provide expert guidance and ensure that the bonding system is properly designed and installed. 38. Regular inspections. Conduct regular visual inspections of the bonding system to check for signs of corrosion, damage, or loose connections. Address any issues promptly to maintain the integrity of the system. 39th. Testing frequency. Test the bonding system at least once a year to verify its effectiveness. Use a low-resistance ohmmeter to measure the impedance of the bonding network and ensure that it meets the required standards. 40th. Keeping records. Maintain detailed records of all inspections, tests, and maintenance activities performed on the bonding system. This will provide a valuable history of the system's performance and help identify any trends or potential problems. 41st. Complying with standards. Ensure that the bonding system complies with all applicable standards and regulations, including the National Electrical Code and any local codes or requirements. 42nd. Staying informed. Stay informed about the latest developments in bonding technology and best practices. Attend training courses, read industry publications, and participate in professional organizations to stay up to date on the latest information. 43rd. Safety precautions. Always follow proper safety precautions when working on electrical equipment. Wear appropriate personal protective equipment such as gloves and safety glasses, and energize the circuit before performing any work. 44th. Avoiding shortcuts. Avoid taking shortcuts or compromising on the quality of materials or workmanship when installing or maintaining a bonding system. The safety of the pool depends on the integrity of the bonding system. 45th. Seeking expert assistance. If you are not qualified to perform the work yourself, seek expert assistance from a licensed electrician or electrical contractor. They have the knowledge, skills, and experience to ensure that the bonding system is properly installed and maintained. 46th. Providing education. Provide education and training to pool owners and operators on the importance of bonding and the proper maintenance of the bonding system. This will help ensure that the pool is operated safely and that any potential problems are identified and addressed promptly. 47th. Promoting awareness. Promote awareness of the importance of bonding among pool professionals and the general public. This will help ensure that all pools are properly bonded and that the risk of electrical shock is minimized. 48th. Collaborating with authorities. Collaborate with electrical inspectors and other authorities to ensure that bonding requirements are properly enforced and that all pools are in compliance with applicable codes and regulations. 49th. Continuous evaluation. Continuously evaluate the effectiveness of the bonding system and make any necessary improvements or adjustments to ensure that it provides the highest level of protection against electrical shock. 50th. Setting a positive example. Set a positive example by always following proper bonding practices and promoting the importance of electrical safety. This will help create a culture of safety and ensure that all pools are operated responsibly.